Hi everyone, and welcome to what's going to be a 3D printing video, and we're going to be solving another one of those first world problems. I've got a number of Raspberry Pi computers and Asus Tinkerboards floating around the place, as well as a Gigabyte bricks as well, and I could do with tidying those up somehow. If you remember in a previous video, I built myself a 19-inch rack, essentially from scrap wood, for the kind of studio, whatever you want to call this, music room area. And I think what we could do is rack mount the Raspberry Pis rather than using this collection of shop bought and 3D printed Raspberry Pi cases. So let's head over to Fusion 360 now and get designing. So here we are in Fusion 360, and as ever we're starting off with a sketch, and for this one I've taken the dimensions for a standard 19-inch rack panel and the mounting points off of Wikipedia, I think I got this from, transferred it to the sketch, so we've got this repeating pattern of mounting holes down each side, and we can obviously use a repeat on that if we need to, or cut some of them out so we can make other panels like this one here, which is just a blanking plate, and we can actually fill in some of the gaps we've got on the rack as well while we're at it. But anyway, back to the Pi rack. So first thing we need to do is get that extruded up so we can make a nice slab there, and then we'll draw in with another sketch. You can see under there essentially the apertures for each of the Raspberry Pis, and also like a mounting plate which is going to fit into this plate. So we'll push through the mounting holes for the actual Pis themselves, which should fit through that. Then we'll put this recess in, which is essentially where the plate will sit into, and we'll make some holes and thread those so that we can actually screw these Raspberry Pis down once we've put the essentially blades into the rack. Then we'll use another sketch just to take some of this material away from here, otherwise we don't want all this thickness here, but we probably do on the back for the actual plate itself, but where it mounts onto the rack we don't want that to be so thick, otherwise we'll need really long cage nut bolts to attach that to the rack. I've also made this so we've got essentially sets of 3, because what I'm going to do in a minute is split this plate into 3 sections so I can fit it on my printer, and also because the Raspberry Pis will be mounted into the front of this, they're ports for things like USB and LAN will be sticking out the front, as it were, so we'll need some cable access. So that's what these slots here are for, and we're only using one, and we'll also take away some more material, tidy things up. Then we'll look at the plate itself. We can use the same shape that we've used for the plate, and we can also draw out, and again you can get all the dimensions I think from raspberrypi.org for the actual Raspberry Pi front plate, and then we can just extrude our plate out, extrude the holes, and they don't need to be threaded. Okay, and because we need a bit more clearance in here, we'll take some more material out of these apertures and then still leave us with these mounting lugs, and then we can start splitting this. We use a dog leg, I guess we might call that, I'm not sure. But anyway, we use this shape here so that we've got a good surface area to apply some epoxy resin when we glue these components together again once they're printed. And so we've got the left and a right section and one in the center, and then what we've done is we've extruded a plate out of the back, shifted that around so it's aligned properly, cut a hole out the middle, put a couple of standoffs attached to that as well, bit of chamfering here and there, and then what this is now is a mounting bracket for the actual Raspberry Pi, and these 2 standoffs with their threaded inserts, or threaded holes rather, correspond to the mounting holes on the Raspberry Pi. Then what we can do is we can start looking at making a handle on the front. Now I did originally start with this concept, which is essentially just a lofted bracket on the front, but there was no easy way to essentially screw this onto the Raspberry Pi front plate, this blue plate here. So as I beefed that up, put a mounting hole in, made this a bit smaller but also a bit taller so you can actually grip hold of it, and you can see there that I've added some mounting holes. And the good thing about this is you can put one bolt through this handle, through this plate, and actually screw it into, you can see the thread there on the mounting bracket, so it clamps the whole unit together, and then you've got your Raspberry Pi screwed onto this bracket at the back here, and it's held pretty sturdy because it's seated in these holes for both the two USB port groups and also the LAN port here. Right, now I could have repeated this all the way down and had 9 Raspberry Pis mounted on this, but in my instance I need to mount a Gigabyte Bricks PC into this right hand one, so essentially cut out that, a bit of filleting on the corner there, and we need some mounts for that as well, so we put some tabs out, drill some holes and then thread those, and what we can do is we can put some M5 grub screws in there which will just hold the Gigabyte Bricks in place. And we also took a little bit more material out of our Raspberry Pi holes, that's fine. Then I needed also to mount a HDMI switch so that I can switch between the outputs, video outputs of both the bricks and the 3 Pis we've got in this. Using a concept similar to the cockpit where I mounted the amplifier in, I made this aperture which matches the HDMI switch, and then some mounting holes, but what they will mount is a collar which will fit around the switch, and then screw bolts in to attach it to the frame, and it will be holding the switch in place. And there's a couple of grub screws you can see there just to basically make sure that we've got the actual switch clamped in there. We're almost there, so the only other thing to do was make holes where I'm going to put some on-off toggle switches between the power supply units and the Raspberry Pis, so we can turn those on and off from this front panel. Okay, so we're pretty much done here. We've got a fair few components to print out, so let's go over to the 3D printer and get these output. Okay, nothing exceptional about these 3D prints other than we're using a brim to hold the parts down, because wide area parts like this have a tendency to curl up at the edges as the part cools, so that just helps stick it to the bed. And talking of sticking, or rather preventing sticking, we'll use some tape with some non-stick backing on it on this cutting mat, so that when we epoxy the 3 sections together they don't stick to the cutting mat underneath. We'll just put the drill on top to hold it in place while it cures, and then we've got our plate ready to go. And then it's a case of soldering up the switches. So we mount the switches to the middle plate on the rack plate, and basically cut the wires from the transformers for the Raspberry Pis and solder the switch in the middle of those using the red or positive lead. And then it's a case of mounting both the Gigabyte bricks and the HDMI switch into the 2 cutouts that we printed, and then we can mount the rack unit into the rack itself using standard cage nuts and bolts. Then we can head back over to the printer and start printing out the parts for the actual Pi blades, I suppose you could call them, themselves. I use some support material you can see on the handle there, because otherwise you wouldn't be able to do that big overhang. And the bracket can just be printed straight off the bed. And then it's a case of putting some M3 bolts through the handle, and then which goes then through the plate and then into the mounting bracket on the back there. That clamps the whole thing together. The Raspberry Pi is already kind of held fairly sturdy by its ports, you can see on the plate there, and then we put a couple of screws in just to hold everything sturdy, and it's all nice and secure. And then we can head over to the rack and start mounting those in. I think I used M4 socket head bolts just to mount those into the rack plate there. Okay, we're pretty much complete. I haven't got a third Pi, but I'm sure I'll get one in the future. They're pretty inexpensive, but we've got our Tinkerboard here, Raspberry Pi here, we've got a HDMI switch with remote control, so we can switch between all 4 of these computers on this rack and also the one at the bottom here, and display that on the big screen there. And we're pretty much done. All very nice and neat, so worthwhile rack mounting your stuff. Okay, so thanks for watching, and I'll catch you on the next video.